Okay, so welcome everyone. My name is Barka Herman. I'm a developer advocate at StarTree, which is hosting this series on Apache Pinot. And we have two presenters today. Some of you already know them, Mateo and Luan. And with that, I'm going to give the floor to Mateo and mute myself.
Right. So today we're going to start talking about how the different methods and the different indexing strategies that you can use alongside with Pinot. And I would say in advance that there's quite a few indexing types. That could be a little bit confusing, but hopefully at this presentation, I'm going to be able to give you like a highlight and an overview about each one of them alongside with use cases. Mateus, can you just zoom a little bit and just go to the bottom a little bit? Yeah. So just quickly introducing Pinot for the ones that doesn't know. Pinot, it's like OLAP real-time database system. So basically it allows you to receive data from different source systems and you store the data in such a way that query is going to be blazing fast. So basically we like to think as Pinot as like a database in real time that allows you to scale up different, I would say, capabilities and different components within the cluster. And it's broadly used on LinkedIn. It was donated by from the Apache Foundation in 2015. It entered incubation in 2018. And in 2021, it became top-level project. The StarTree, which is the company that accelerates and just pretty much works on the development and the build out of the new features. It was founded in 2019, and we have seen now not only LinkedIn using, but also other companies such Uber Eats, Stripe, so on and so forth. And it's quite interesting to look at the history because since the beginning from 2018 to 2022, there's a bunch of things that happened, not only on the technology side, but also at the overall data analytics spectrum. So now we have seen more often customers asking for real-time analytics, right? I think we were able to unlock the real-time ingestion with Apache Kafka, but at the same time, we were kind of having some difficulties not only to perform analytics on top of real-time ingestion systems, but also how we could query this data that are frequently accessed, and they need to get a response in real time. So that's why we started to see this concept that Mateus just pointed out on top, which is the user-facing analytics. So user-facing analytics allows you to query data in a fresh state as soon as possible. And then by doing that, you're going to be able to unlock new streams of revenue, streams of capabilities that you can unlock on your system. And today we're in 2023, and there's a bunch of things happening at the StarTree community and at the Pinot community. A lot of meetups being held for this topic. A lot of new members contributing on the code. 270 contributors, more than TK, 10,000 commits, and 100 deployment processes. So there's a bunch of going on. We have seen a huge traction about it. And we're super excited to talk to you about the indexing capabilities.
Yeah, let's go over a little bit about this guy for you guys to understand how big Pinot is. So we have like the ingestion type, or two types of ingestions. We have the offline tables and the real-time tables. So it's not only, everybody thinks that's because of Kafka, because it has like this best in breed, this match made in heaven with Apache Kafka. He only works with real-time ingestion, but it has the offline ones that can create ingestion jobs to push data from blob storage, S3, GCS, to load this in the segment store, to be queried by everybody. Right? The whole idea is to have the high concurrency as possible. So we have use cases that has millions of users. For example, LinkedIn is one of them, has millions of users requesting queries inside of Pinot with clusters that if you think of they are not huge clusters for the size of how data is stored and is retrieving. So it has a really complex. I think we're gonna have like to push this on the call, because I think we go over this whole architecture, this whole components that you have. There's a lot of things to digest. So I want you guys to see a little bit how it works behind the hood. But let's go to the index, because that's the main goal of this talk. So guys have to think of that it is huge.
But Mateus,
before,
you pointed out something important. I think one of the key major aspects for why Pinot has arisen on LinkedIn is because of the fact to reduce drastically the amount of usage in terms of computational, right?
Mm-hmm.
So I do recall that we were in a podcast with Kishore Gopalakrishna, which is the CEO of StarTree, where he was basically explaining about the challenges that he had back in the time with LinkedIn, that they used to have lots of machines running to perform some computational queries. And the idea of Pinot was kind of to drastically reduce. So you can just do a bunch of computational using the best in breed, techniques, and still, using less resources than different other technologies such as Druid or ClickHouse, so on and so forth.
Yeah, and with more. And I like to make a special shout out for the Pinot community that has been like a huge family. I see a lot of things on the Slack channel. I see we have a lot of meetups, people building videos, content about Pinot. So thank you for that. For the all-star members, that me, Luan, had to be a part of this group of content creators that especially going in each day, try to see what we can learn, what we can best transfer the knowledge, how we can make more easy for people to do the adoption of Apache Pinot, and the PMC members that make everything happen. So it's a completely open source product that has been, we saw I make I think a few weeks back a roadmap, a video about the roadmap 2023. It has a huge pack of new things that are going to be on this year for us. So it's a completely open source solution that has been accelerated by the community. That's most important. People think, okay, it's not only a company, this is a community that is driving this product. So thanks StarTree for that, in all the Pinot community to do that. So let's talk about indexes, one. I think that's the main goal.
Yeah, I think on the ideal world, like Mateus, we should plan the queries in advance, right? But we do know that it's a little bit more complex than that. So systems such as Cassandra, where you have to plan the query in advance because of the column family, kind of Pinot allows you to not only specify the index, however, it's mandatory that index is created for each table that you have within the system. And we're going to delve a little bit on that on the further, topics. But basically, what an index is, right? So just index, it's a way in how you're going to efficiently find information within a table. So let's say, for example, that you would like to query a table without an index. So as the same as a book, for example, that doesn't have like the table of content or the glossary, you don't have a place where you can see where the data is. So you're going to have to skim over through all the book in order to try to find a specific place. Whereas if you implement an index strategy inside of the table or within the book, and you can use the same concept, then you're going to have like a table of content where you can see, okay, I would like to search for this term. And then you're going to see where, in which page that specific information are. So you're going to be able to dive and go way faster. So index works as the same way here. So it's a way in how you're going to build a structure, optimize a structure for you to query the data. So now users, whenever they hitting queries or issuing queries against the system, in this case, Pinot, is going to be easier and rapidly access the data. Right, so let's take like a quick example here. You have this concept of primary key or primary index, and the secondary ones. In a normal relational database, you have one primary key per table, and usually whenever you issue a primary key within the table, it creates you an index. And in the way that the index is created, it's just built like a B tree structure, which is binary tree. Just go a little bit down, yeah. So basically the B tree has 3 different layers: the root, the intermediate, and leaf level. So it's the same as book. You would like to query or find a specific name, for example. Then you're going to go through the root. The root's going to give you some intermediate levels. And from the intermediate levels, you're going to have the leaf where the actual data resides. And then you're going to be able to retrieve it fast. So simply put, you can, in 3, I would say, operations, be able to find whichever data or that is indexed you want, meaning that's going to be super fast for you to query the data. However, when you create an index, you have to specify a type or a column, for example. So if you query for that column, query is always going to be responsive. However, if you specify a different column, it may not be optimal because you don't have indexes on that specific column. And, you know, just the same applies to Apache Pinot. Apache Pinot also offers you not only the binary tree option, but also it has more than 7, 8 different types of indexing strategies that you could use. And the reason why Pinot gives you this breadth of options is to make sure that whichever query you want to hit against the system, they're going to have different and special indexes to fulfill that request. Go a little bit down, Mateus, please. So in Apache Pinot case, by default, if you're building your table and you don't specify any indexes behind the scenes, Apache Pinot uses the dictionary encoded, which is the forward index, and builds that table for you using the forwarded index. This is default one. It could be changed. You can either specify this on the ingestion config on the JSON file, or you can dynamically change or add, you know, different index strategies. So let's say, for example, that you have the forward index and you want to build another index. You could go to the table index config and you can change this configuration behavior and apply changes. One of important caveat here is that depending of the index that you're changing, that would imply a full reorganization of the segments, and that would take some time to do it. So bear in mind that some indexes are going to be transparent. They're going to be able to get and leave the same segments intact. And segments, for those that doesn't know, segments are basically the location, physical location where the data is stored. Data is stored within the Apache Pinot disk structure in the segments. So you have segments of the data, usually compressed and grouped by columns. So you have lots of segments, and you have the segments throughout the organization of a column based in a column organization. Yes, you can just go down. And I think I'm going to pass over to Mateus to explain, you know, starting to be acquainted, Mateus, with these type of indexes, right? And then Mateus is going to explain about this default one with the forward index that I mentioned above.
Yeah. So let's start with the first one, the one that we don't need to specify. Is the default one. It's a dictionary encoded forward index. So what he does, he creates a dictionary for each column, a dictionary ID based on column, and then he creates a doc ID based on the value. So for example, I have this column, my table, and I say, okay, I want this column to be, okay, it was a which column, but let's pick it up this column, and I want to be this one is, my doc ID is going to be 0, is going to have this value, the 1 is going to be this value. So he likes encapsulate this inside of a doc ID. So this is the default one. This is the way that he makes to make queries more faster, to not only throw data inside segments, and then how we gonna query in a fast way. And if I don't have in advance the information about each value that I have. So this is the default one. If I don't specify, I'm gonna use this one. You're gonna create for me out of the batch, which is the first. Again, guys, this is what you're supposed to say something.
Yeah, no, I was just about to say that. I mean, if you don't know, and sometimes could happen, right? We are talking about indexing strategies, but maybe depending of the table that you're going to release to the customer, you don't know yet until that moment which index type you're going to use. So no problem at all. I think you could use the cookie cutter approach, which is using the default one. You start with the default one. And when you start to feel that query response time are getting a little bit slower, or you're not performing well, or you're seeing that the overall systems are being overloaded due to the query response times, then might be the time for you to understand the query footprints and then plan for a different index, which Mateus is going to explain now.
Yeah. So I start to see my query is not running as I want, so I'm going to take one step further without changing so many things. So I go to the next one, that is sorted forward index. Like I told you guys, he creates the idea of dictionary, the docs. So how I can make data when I have the data sorted, like in a lot of different places, the same ID. So what we do is we create this configuration sorted column. I pass this name of the column, and then inside of the doc ID, he's going to create for me a member ID based on the doc. So for example, just for you guys to see, I have this column. This is the employees ID, okay? And then I know that the column ID 0 is this member ID, but this same member ID, this information about this employee, it has more than one time on my database. So I need to know whatever this new type of data, new row is on my table. So I know that now he has on 100, the doc ID 100. What he does is he make the sort, and then he has like when he start on this doc ID and end on this doc ID. So I have the sort of like a range, similar to range, but internally, only internally for him to query. So I know that it starts for this one, 0, and I know that has like another one called 100. So this is how the sorted one work behind all the bat. And I have to put this, don't forget, I have to put this configuration, okay, on my JSON file. These are the two first ones. Now we have to, Luan, that's a good one to get like this. Let's invert the role. Let's like, now it's your time to talk about the inverted thing. I know I have one more. I forgot. Oh, I'm making a mistake. I'm crazy. I have one more. I'm like, see? I was tied to the invert before. And the row veil format is based on, how can I say, instead of I create like in the sort of, I create chunks based on the doc ID in the chunk size. I put, okay, this is going to be my chunk size. This information that I want to have easily to connect. So I don't use dictionaries on this one. I don't use it. I just pass a column and it separates in the chunk based on the size that is of my data. So for example, I have the chunk 0. You have this amount of data is going to be inside of a chunk offset. So it's going to similar to Kafka in a way, like it has the points based on the chunk, which offset that I have of data in which data that I'm going to query. So it's more like an advanced one in this case. But when I have a lot of raw data, I want to work more raw. The data is something that's not easy for me to query. I don't have like specific type of filter, for example. So I use the raw data. So now is your time. Now is the inverted one.
Yes. So the inverted index has like a special case, and it's interesting for us to explain about this one. So inverted index allows you to kind of reduce the time to access the segments that your query are trying to request from. And usually we use the bitmap inverted index whenever you have a frequent used column that we filter. So let's say, for example, that if you check the table, we have employee number, we have the employee name, department ID, department, UF, and POS, for example. And let's say that you would like to, the queries that are issuing against this table are using the where clause on the UF or the state. And the state has a high cardinality because you can query only 26 states. So what you can do in order to fasten your query response time is to implement a bitmap inverted index on the columns that you think should be like frequently accessed. In this case, let's say, for example, that I would like to query whenever I'm issuing a query, I'm just querying through the UF, right? And then I'm just going to create a bitmap on the UF. And what it does is that it creates a bitmap, I would say area, like you see on the screen, 00100, which means São Paulo, 10, 100, that means DF, and 11001, which means MG, and then it fills up for each one of the files, for each one of the rows that we have, distinct rows that we have. And then it's going to create a bitmap index. So whenever you issue the query, it's going to go for this bitmap location, finds what is the relation, and then retrieves that information for you. So that's going to be super fast. However, the bitmap index, inverted index, whenever you have much rows that you have to put in the bitmap, that may overload a little bit the system. So that's where the sorted inverted index comes to play, right, Mateus? So just, just go, So let's say, for example, that you implemented successfully the inverted index. Now you're doing your where clauses on the UF and you're retrieving pretty fast. But now let's say that implemented the bitmap on the department ID. And department ID has like a low cardinality, means that there's a bunch of numbers, different numbers. There's more than 1 million departments. I'm just guessing, right? I know 1,000 or 10,000 departments within your company, which is worldwide. And then the bitmap may get some latency in terms of decoding that information at one time. So one of the advantages that you can take is to implement the sorted inverted index, which is basically, it's going to allow you to sort, not only to create the inverted index bitmap, but also to sort it out that. However, you can only sort the data for one column. It does not allow you to have more than one column for sort. So meaning that if you want to use the sorted inverted index, you should have to know that you're only going to be able to apply for one column per table.
Yep, and then we began to talk about the star of the night. I can say we saw a lot of indexes, strategies. We're gonna see a lot of more, but this one I want you guys to always remember to take a look on this special one. This is StarTree index is the Pinot custom index made for the team, for the Pinot team, to sort out a few problems. For example, when we do the index, we have a lot of time to index all this stuff, but we have to do in small space. It has to be a small amount of data. I can index a large data set, for example, because it doesn't make sense, because we're going to make a scan and all this stuff. In the other side, I need, for me to do a pre-aggregation of, for example, I need to count something. I have a lot of time to take because it's a lot of data. So It's a trade-off. It is something that everybody here must know, that when we work with technology, we're not gonna always, it's not a win-win. It's you win something and you lose something. You get more fast computation, but you have to need a more better machine for that. So on and so forth. So the idea of a StarTree index is to make something easy, is to pre-aggregate a column based on the functions to be more easy to query that data. So if I always have this pre-aggregation done for me in a space inside of a tree, it's more easy for me to handle. So I don't have like a huge amount of, I don't have like a lot of space to take. I can have too much because I need to have a threshold. I need to specify how much data I want to, how is my threshold for that specific dimension that I'm creating. But I can make the balance. I can have like a good response time, and I can have like a good space or a good amount of data be retrieved. So normally what happens is this. I'm going to show this one because it's more easy. I have the root one, then I have the dimensions, and I have these, the yellow ones at the StarTree dimensions. In these ones, inside of my index, it shows like, okay, I have a function, I have a pre-aggregation inside of this space. So it's aggregating data, it's aggregation data. So it's more faster for me to get it, but I have to pass, like again, a threshold. For this example, for example, they're using 10,000 for the threshold. So I have a threshold for each dimension that I create on my index of 10,000 for retrieval. This way I can pre-aggregate again. So if I put like 1 million, 2 million rows, 1 billion rows, it's going to be fast. No, it's not going to be fast because you have like a huge threshold. So you have to do like the trade-off. If I want something, okay, I have like, I give an easy example. I have like 10,000 rows per minute. So I can use the pre-aggregation of 10,000 for my threshold to have this pre-computation done for me. When I query this data, done. I can retrieve it. It's all good. So the StarTree index, and it makes sense, okay, because the StarTree company is like, was deputized, it had the name, was given the name of StarTree because of this index, because they built this from the ground up to make Pinot even more faster based on trade-off. Okay, so now let's see how this works internally. So I have the root, I have my dimensions, I have my leaf nodes in the B, similar to a B tree, but I have this aggregation computation inside of a node. So I have like, okay, I have my pre-aggregation done here in my dimension. I can only request, okay, if I'm querying this data, it has a pre-computation about some, for example, already retrieve that data. I don't need to do anything else. So the StarTree for me is one of the best indexes, but again, careful. It comes with a price. You have to make a threshold. You have to understand a little more about your data. It's more advanced type of indexing strategy. You can just push and then other functions. And they have the documentation is pretty huge, it's pretty complete. So it has like, if I'm not mistaken, 7 types of functions, 6 or 7 types of functions, count, sum, average. You guys can take a look and see if it has some function that you guys can pre-computate, pre-aggregate beforehand. So this is one of the best, in my opinion. But not only this one, we have this guy, the Bloom filter.
Yes, Bloom filter, it's another one, right? So Bloom filter, it's basically, it's a pretty straightforward one. It serves to perform matching equality predicates if exist or not exist. Right. So for example, let's say that we have a query that searches for a specific employee number. So basically what the Bloom filter does is just prune the segments, and pruning the segments is a really important topic here. Pruning segments means that I'm gonna not look over these segments while I'm querying the data store on Pinot. And that's where it makes query faster, because you don't have to go for that specific segment, because the Bloom filter already taken that out from the query planning, I would say. So you can use this whenever you would like to match something. So exactly when you have, for example, a specific column that it has a bunch of segments, and you want to do equality queries like player ID equals something, user ID equals something, and you would like to check if that number is false or positive, if exists or not exist. And for that, you have like 3 different, I would say, configuration options that you have to enable in order to configure the Bloom filter, which is this FPP, which is the false positive probability. You have the max size in byte, which is the max size of the Bloom filter per se, and the load on heap, which allows you to use the memory or not. Usually this is it's set as false, which means that it doesn't use the memory, because let's say, for example, that you have a huge amount of segments to prune or to query, and then you ended up having like to put that information in memory. It could kind of put some hard time on the broker per se, or on the segment store that are querying it.
Yep. You talk about range? There is
range.
Most simple one, right?
I think range is pretty straightforward. So let's say that you have a query that usually it always comes with a range. I'm not going to use timestamp here, because we do have a specific index for timestamp queries. Like if you would like to query for month, year, day, usually before I don't remember the version on top of my head, Mateus, but I think it's 0.8. Prior Pinot 0.8, if you would like to make like range queries for timestamp, then we would use like the range index. But now, after the 0.8, Pinot has released a new index capability called timestamp, which I'm going to explain briefly on the next few slides. So, but let's take into that. Let's say, for example, that you would like to query salary range, or let's say range would be a good one. Do you have a case on top of your head of range?
In the case that documentation is like a salary or something.
Salary would be a good one.
Greater than.
Just a range between 1,000 and 7,000, or 100 to 1,000. When you have to specify a range, in my recommendation here is that range that are not tied up with timestamp, because now we have a specific index to deal with timing, which is even more performant than the range index.
Yeah, agree. This one is good. One of the main, how can I say?
And this is underrated. A lot of people doesn't know that Pinot does that, right?
Yeah, a lot of people doesn't know. So the whole idea of querying text in the native way is something that most of people doesn't know, but Pinot has an index to do this. Usually you use like some functions like text contains, text max, text match for you to run against a text. But it has like, and I can say this, was built for the entire ground up, is a custom index engine for that. So it's something completely different. It can get like to 80 to 120% faster than Lucene based index text search. So it's pretty fast, and support real-time text search for real-time tables. So we can use, for example, I have like a logging that I receive like all the time. I put in this case, I use like the feedback text because the employees table to keep the same. But the whole idea is I have like a log and I want to specify to see some text, a base text, error or malfunction, something like that in the log. So I can use this, query this ingest this into Pinot in the real-time table and query pretty fast. It is pretty simple, the configuration. You put the encoding type raw, you put the index type text, the property you specify that is native. If you don't put this, he goes to another support text index that I put here. That has a few restrictions, but not that bad. But usually we try to use the native one. But we have another one that is text search support, that you can specify the columns, specify there is a text that you're going to receive, and I can query this data. What is the restriction on the text search support? The column type should be string. The column should be a single value. And in this case, it doesn't have the coexisting with another Pinot indexes. So I can use only this index on this table if I want to. I can leverage other indexes if I'm using the text search support. If I'm using native, I saw the documentation, didn't see any restrictions on that. And it has a lot of things on the documentation to use this one.
So Mateus, would it be fair to say that we could create a specific table that only gets like the texting? That would be the best approach for that. Like, so let's say, for example, that we're collecting logs from the applications, and they would like to do queries on top of that instead of using Elasticsearch, for example, because I'm using Apache Pinot already to offline tables and real-time tables. And instead of having another Elasticsearch or another engine, I would put everything in one and then design a table with the text search. That would be the best approach.
Yeah, in this case, I can do even more. You can do this, the native one, and then I can specify the column that I'm using, and then participate. I can use in other indexes. Yep. On the native one, I can use more than one because I don't see any restrictions on the native. Only if I'm not using native, I can have a restriction of only use one type of index. But that is a pretty good one. It has the JSON one. The JSON one. I don't know anybody that doesn't use JSON nowadays. Not even
Nobody uses.
Data engineers are using.
Nobody.
So the whole idea is how I query data using JSON. So if you have like a nested type of JSON, has a lot of columns, what by default he does? I send the query, he flattens the JSON to make the query. But imagine I'm using one record in this case. Look how much computation it has to do, because it has to take apart and then identify, break the JSON, normalize the JSON in the type similar to a table. So it's not easy. But we have like the JSON index. The whole idea of the JSON index is to make more easy to scan, to access and filter JSON file strings without having to scan everything. When I can say the max level, okay, I want max level equals to 1, for example, the first level. I can only have like these two, the name and the age of Adam. Now I want the second level. Then I get the name and the skills of one, because this is one level. Let me put here, this, I'll do this easy. Okay, let me do this. This is one level, right? And this is the second level. So I can put this third level, I can go over in this. I can exclude arrays. Okay, I don't want anything that has array. For example, addresses as array, so I don't want arrays on this one. I can disable unnest arrays. Okay, I can break in the array and transform in nested in the flattened one. I can exclude some paths. Okay, I can put this path I don't want to worry, I can pass. I can include the path. Okay, this path I only want to get this path on the index. And pretty straightforward. I think the whole idea is to make it more easy for us to query inside JSONs. So the JSON files, the JSON tables, right? Because I don't know if you guys know, but Pinot has the full support for JSON. In this one, I'm in a project that people are start to test it out. The geospatial index. The geospatial index is based on the H3 Uber pattern for geospatial hexagonal grid. So what he does is he take a map and he draw a lot of hexagonal to create a polygon to say, okay, this is this part I'm reading, this is the part I'm reading, this is the part I'm reading. So he creates the other ones. Imagine to identify the red circle, he has to draw the polygons to say, okay, this is the part I want to see. The main idea of this one is to use, for example, I have like a delivery type of application that needs mapping, that needs something close to the similar, Uber is the first one. So I was going to use Uber as example, but to use it similar as Uber to support the geospatial functions to make more faster. So the whole idea is to use this pattern. If you have like application, they use the H3 pattern for drawing mapping, for working with mapping and geospatial queries. This is for you. So the whole idea is to pass the type of index, to specify the resolution, and to, okay, this is a no dictionary column, and you specify the column that they're going to use. I use the Starbucks storage in this case to say, okay, why the Starbucks are on New York? So you can draw and see on the map. The whole idea is to make more easy for the Uber users in Pinot for everything inside of Uber. Timestamp
Luan. In the last one, in the last of the night, it's, as I said, it was this feature is supported from Pinot 0.11 plus. So Pinot introduced the timestamp data type. So I said it before that was available on 0.8. Correction here is just after the 0.11 onwards, right? So my apologies. So the timestamp data type had been introduced on Pinot from the 0.8 release. Prior to that, we didn't have the capability of the timestamp per se. So now, since 0.8, we do have the capability to say that the specific column is timestamp, which means date plus time in milliseconds. So that data is stored in the millisecond epoch, right? So you just have the whole length of the timestamp time. And after Pinot 0.11, they roll out a new index type called a timestamp, which allows you to do, queries over the timestamp. However, it adds a lot of, I would say, it comes with all the bells and whistles, Mateus, because you not only are able to query the timestamp. For example, I would like to query from that date, 2022-04-13, 3 p.m. to same time, 10 p.m., right? And then you're going to get the range. But also, you can delve on the year, month, day, and is still going to be performant. So when you're specifying the timestamp column, you see that there's a column saying granularity that you can specify. So that's how Pinot is going to build up the segments and break it down, that information into the storage layer. And as you can see, you have the granularity per day, week, and month. And if you just go over the documentation of Pinot, it's pretty impressive because they did a performance test against a query that was using the normal index strategy with the Ford index and range index, and they were having the response time from 45 just scanning, the benchmark was scanning just the query performance over 2.7 billion records. Thank you so much, Mateus. Yeah, this is the exact place that I'm looking at. 2.7 billion records. First, implementing the forward index, which is the default, and trying the range index, you were able to get 45 seconds, which is pretty decent, but then plummet to, when they implemented timestamp, to 4.2 seconds. So it's just huge improvement, aggressive decrease of time response time. We're just, reducing more than 10 times or 8 times faster response time, wicked fast. And that's how they were able to get it. So now, usually I would say that whenever you query data over time, I think the timestamp should be your great ally, right? And I think to sum things up, to wind up the conversation, but there was nothing better than deliver them like this, this easy to check when to use a diagram, right? So this is, we pull up like this information for you in order to make it easier for you to understand which type of index should be used and in which, I would say, occasion you could use each one of them, right? So what I'm going to do is that once we finish this talk, I'm going to share with Barca the link. Mateus, can you export this on PDF, please? No. We're going to export this on PDF and we're going to send to Barca so Barca can put this somewhere where everybody could download this and have this like guideline for you to use whenever you want to design or implement an index strategy in Apache Pinot.
That was fantastic. I learned so much.
Thanks.
So do we have any questions from the audience?
Yeah, do we have any questions? Maybe what is an index, right? Just, what is this all about? What is an index? Okay, I would start with this question, possibly, if I start green on Pinot. But yeah, Mateus, any comments about, okay, question for you, Mateus. What are the most common index types that we have been using in our endeavor with Apache Pinot? Because we have some customers using it in production. So I would like to hear from you, what are the most common used indexes that we do have implemented so far?
The StarTree one, and I have a customer that is testing the geospatial one. That's trying to see, but he's in another type of pattern different for H3, so they are seeing if this fits. But they are testing. They're testing this week actually.
I know that we are evaluating Pinot and Trino, right, in terms of querying geospatial information. So that would be interesting to understand how Pinot is positioned in terms of querying geospatial data. Yeah, I have some cases on the timestamp index, which I'm just kind of working a little bit right now, specifically for queries that we do have the source system as Apache Kafka. So since it's a timestamp, and we have to query data over time, and we have a timeline, timestamp seems to be proven like way faster than the usual range or the forward index capability, which is the default. So yeah, but definitely if you have, I think the StarTree is the biggest innovation, to be honest, as you said. So it's a combination of forward index, inverted index, and some capabilities built in within StarTree, and which is pretty impressive, to be honest with you, because usually companies that are leaning towards building a product, they don't offer the fully fledged capabilities on their systems. And Pinot follows StarTree follows a different approach. So they built this StarTree index that improves even more the query response time, and they gave back to the community 100% of this. So now you can just implement whatever you want, and then you're going to be able to use it, the StarTree index. For pre-computational workloads, it's just like a piece of cake. It works
fantastically well, and it's blazing fast how we can just see the data being summarized or sum it up pretty fast, and then you're gonna have like 0 milliseconds response time for these type of things.
Yeah.
So it's just pretty impressive. Yeah, and I think as a wrap, Barca, I just want to thank you so much for spending your time with us. I had a blast by just talking with these people, even though are not too much at the stage, but super glad to put this content out, and I hopefully could serve for people that are putting their feet on Apache Pinot, and they could understand how important it is to design indexes. And just say thank you for Mateus, which is my co-worker and have been working with me for the past, I don't know, years. And yeah,